401k money's converted and get out.
Okay, so this is a General Electric mid-century 427 dial beam receiver. And you can see it's got the dial beam here. We're going to go through how to take one of these that you find and at least make it safe and get it back working again. And this is just one of those All-American 5 type videos where we're going to go a little deeper into the radio and see what we need to do. And notice it says right on, so even though it's a mid-century radio, it was used in the 60s, maybe the late 60s, so I'll probably be saying things like right on a lot during this video. Okay, so I have not done an All-American 5 restoration, so I thought it was high time, and looks like it was used through the 70s because it's got this cool right on sticker on the front. It is a General Electric AM table radio, and I presume it's an All-American 5. Let's take a look. Oh yeah. Yeah, that looks like an All-American 5, all right. 1, 2, 3, 4, 5 tubes, with the fifth being the rectifier, the 35W4. A straight-ahead All-American 5 restoration with a beautiful metal chassis, by the way. Yeah, this should be a fun project. So normally I would be looking for a schematic at this point, or some type of a manual for the radio, if it's possible to find that. First order of business, probably a little cleanup, taking it out of its protective plastic chassis. And I will pull the tubes and test them with this tube tester over here. I don't think they're going to test bad, but that's something to do, I guess, that just satisfies that maybe there wasn't a series heater string problem. Also, I have a isolation transformer. This is kind of a homebrew isolation transformer setup. It's two 5 or 10 amp transformers back to back, forming an isolation transformer. So you've got the 120 side in and out, and then the middles are connected. Now it's not the most efficient type of isolation transformer. You'll find that when you do this, it works. It does give you an isolated circuit, but there will be some heating in the transformers. There's some wasted energy. Obviously, you're stepping it down, stepping it back up again. This thing I put together, it's got an outlet, it's got a circuit breaker built in, and it's got a tap for the middle. I think that's 24 volts or something, or 12 volts. So I can take that off there. And I've got it rigged up so it takes a standard computer IEC type cord to power it. So that's my isolation transformer, the kind of the poor man's version of an isolation transformer that I will use with the All-American 5. Remember, these things work right off the line, and that means that plugged in the wrong way, which is very easy to do because this is a non-polarized plug, you start to fool in there and you could touch chassis and ground, and perhaps there's a capacitor that's broken down between the ground and the chassis that could cause you to get a shock. If you were to come between the chassis and ground, you might get a shock off that. So we do have to be careful to remove it from the chassis. First, pull the knob straight off the front, and then we have 4 1/4-inch nut driver screws to remove. It's actually quite a nicely built radio. So just loosen these up and carefully drop the chassis out. In pulling it away from the chassis, you can see there's a speaker in there. There were 2 clips that went on the speaker right here on the chassis, and those just pull away from the speaker. I am going to remove the speaker so I can give the whole plastic case a good scrubbing. Also, I noticed that one of the IF cans just popped off. It's just a cover for the IF can, so I'll be putting that back in there. We now have a total plastic outer case that will be cleaned. Okay, case looking a little bit better. Right on, right on, right on. Okay, next we want to carefully remove the tubes. He's out of here. This guy's got a shield. Wow, that's high class. You don't see that too often. All the tubes are out. We can probably clean off the chassis a little bit before we go on. So, in totally logical GE fashion, they've got the power supply tube, the 35W4, in the spot that's the furthest away from the most sensitive part of the circuit, which is over here, the converter tube. So the converter that has the oscillator is as far away from the power supply tube as possible. The other heat generating tube, the 50C5, is your power output tube. Again, far away from a place where it can do damage. The detector first audio amplifier stage comes next, and that has a shield. GE has gone as far as to put a tube shield on that stage. Very rare to see in an All-American 5. The IF amplifier goes here. So it's an extremely well done layout, a very well shielded receiver. This is the upper end of All-American 5 type construction. It's using miniature tubes, and it's using a ferrite loop stick antenna rather than a wire-wound loop antenna on the back of the set. I have to believe that General Electric made all of these tubes originally, but there's a whole multitude of different tubes in this radio. This is a tongue saw. This is the 12BA6, measuring good. And what's this one? An RCA, the arch enemy. That could be a GE tube, another RCA, and finally an original GE tube is the detector amplifier. So this radio has been worked on before, and people have replaced tubes in it. I wonder if we'll find any bad tubes. Okay, here's the 12BE6, and it says this is okay if it's over the diode marking, and it is. And the amplifier section of the 12BE6 is good. And the 12AV6 is plenty good. Okay, 35W4 rectifier tube is good. Finally, the power output tube. This is the one that takes the most abuse, the 50C5. We're going to let it squeak by. Okay. It's just into the green paint. This tube is probably the one that takes the most abuse in the radio. It's the audio output amplifier, the 50C5. But you know what? I think it's okay. So the chassis definitely deserves a cleanup. But before we go there, let's just make sure that everything feels right with the... Oh, it looks like it has a pull on off and a volume control here. And this is the tuning control. Oh, it's really stuck. Okay, so we need to free up the tuning control. A heat gun and some WD-40 can get in there. Work that a little bit. Well, that helped already. Okay. Looks like the WD-40 did the trick. Okay, so let's get this blinding apparatus off here. This keeps the light concentrated forward. Little piece of black cardboard. Use the bayonet socket to remove the bulb and look at it carefully, and it is open. I don't even need the meter for this. You can see that this is open. So there we are. We have our first component that definitely needs to be replaced. It says it's a GE44, so it's probably the original bulb. This is actually a 1955 General Electric dial beam receiver. This is the dial and this is the beam. So this light that I'm replacing is the beam. Now, we found out that it takes a GE44 1.5 to 2 watt type bulb, and all I have in stock is a type 47, which is the more common 6.3 volt, 150 mil type bulb, which is only half the dissipation. So in order to make up the difference and allow me to use this more common bulb, I'm going to be mounting a 68 ohm resistor below chassis to take some of the current and make this bulb look similar to the older bulb, which was a higher power dissipation. After one has removed the self-tapping metal screws to release the bottom cover, you can see that a repair artist has been in here before and has inserted some type of replacement for the electrolytic that used to live here. This is very clever. Okay. And there's some goopiness over here that shows that something was leaking originally. That looks like it has to do with something over here. Yeah, something over here must have gotten warm, probably this capacitor here, and leaked out something. So now it doesn't look too bad down here, actually. And by the way, I thought this was 1960s, but just the amount of quality put into the chassis alone should have given it away that it was a much older All-American 5 from the 50s and not something from the 60s. This is really using pretty deluxe materials that you wouldn't be using in the 1960s. So we need to replace these capacitors with something. We're going to need two capacitors. Of course, a dual cap would be ideal, but unless you order something special, you're probably not going to find something like that. Here's what not to do. Here I found a supposedly perfect capacitor. It's 215s at 300 volts. And look, it would even snap right in. So, wow, look at that, huh? Doesn't that look like it belongs in there? And it's even self-grounding. Well, the problem with that is that it is self-grounding. So the negative lead is going straight to the chassis, and that's going to cause a direct connection to chassis, and if the plug is plugged in the wrong way, you're guaranteeing you're going to get a shock when you touch the chassis. So we do not want to use something like this with a metal type case on it. And if you did, you'd have to really insulate it very well to snap it in there without it shorting out. Instead, most people are just going to take a pair of capacitors like this, kind of like they did here with these four, and put them in. These are a couple of 40 microfarad 450 volt caps that'll work just fine to filter the little All-American 5 receiver. So how do we mount these fine capacitors? Well, we could do what they did here and just wrap everything with electrical tape and stuff it in there. But I think that a fine leaded capacitor like this, or one that has the leads coming off the end in radial form, which is more common, would like to have a nice terminal strip. See that? So we're going to mount a terminal strip down in there. I am curious, and you should be curious too, to see what the repair artist put in there originally. Beautiful Sprague, 20 microfarad, 200 volts DC, 40 microfarads at 200 volts times 2. And I'm going to be replacing that with 40 microfarads at 450 volts times 2. Anytime you open up a piece of vintage gear, you're going to find line capacitors that are probably standard paper types, and these will be a very dangerous thing because usually they put a capacitor right across the line, and they also used another capacitor to go from the line to the chassis. I think it's this one here. Yeah, that's the ground, the artificial ground, and over here the center of this socket goes right to the chassis, and they've actually welded it to the chassis. So This capacitor is a paper capacitor. It's being used between the chassis ground and the reference ground. This capacitor is right across the AC line. I see that they used a high quality Black Beauty capacitor right across the line after the switch. I can't remember, is the Black Beauty capacitor good or bad? You guys will have to let me know in the comments whether I should leave that Black Beauty in there right across the line. I'm just kidding, of course. All of these have to come out, and modern day safety capacitors are rated both for across the line, those are called the X type safety capacitors, and then from line to chassis, that is known as the Y type safety capacitor. So we are going to be using these X and Y type safety capacitors, and they'll be put in place of this guy and this guy. The other capacitors can be standard Mylar types that you're probably more familiar with. So we'll be using something like this to replace those two. So I would like to take a look at the bottom of the chassis and identify some of these capacitors. This is the speaker filter. The line filter is actually this nice orange drop 0.047 600 volt. You can see this exploded at one time and was replaced with this nice orange drop. Now, of course, the prevailing rulemaking today is to use safety caps in both the line filter and the chassis to ground connection capacitors. Both of these were originally paper capacitors with a 400 volt rating, and of course over time they started to leak, and this is a safety concern as well as a fire hazard. Now, do I believe that replacing these with 600 volt orange drops would take care of the problem? Personally, yes, I believe that these would be adequate, but the prevailing law and rulemaking and all equipment that's built today uses safety capacitors in these two spots, specifically something like an X2 here and a Y2 here. C9 is a multi-capacitor resistor module, and it has several capacitors inside. We have the automatic volume control capacitor. This is very important. Typically this 0.05 cap, if it's leaky, the radio will be at full volume, and that'll be the symptom here. So we do not want a leaky capacitor here. We have the filter cap. This is a dual cap, red, yellow, high voltage, medium voltage. This is the one that goes to the speaker. This is the one for the rest of the circuit. It's a dual 50 microfarad. I was very surprised it was that high. I put in two 40 microfarads. I would probably replace this with two 100 microfarad 450 volt capacitors, very common. They could be axial or radial lead. And then this is just a little coupling capacitor used in the oscillator for the converter stage. So let's look at the schematic. Now in the schematic, looks pretty straightforward. It's a classic all-American 5, 1, 2, 3, 4, 5 tubes. It's using the standard tubes that were common in the 50s and 60s. Nothing too out of the ordinary here. I might just point out some of the caps. Here's your chassis to ground connection. I've blown up the internal ground, which is floating, so you can see it a little easier. Here's the 250 microfarad caps in the filter cap, and I put some plus marks on them so you can see which way that goes. I never found this connection, which is a phono input. I did not see J1 as well, so maybe this was something they thought of doing, but they ended up not putting it in most of the models. This is the little 44 2-watt lamp. As you can see, As you're lighting up the filament, it goes through and it lights them like this, and that's where the current is across part of the filament, and we will add a resistor there. So here you can see that I've got the Y2 capacitor for C4, the X2 capacitor across the line as a filter, and I've added a 68 ohm resistor across the lamp, and I'm using a type 47. So a type 47 instead of a 44. It's a 150 milliamp 6.3 volt lamp. What else do we see looking down on this beautiful receiver? It's fairly apparent that these two capacitors have already been changed once, and the replacement in one case was a black beauty. A black beauty in this radio probably was not what was in there originally. This 600 volt 022, that could well be something that was used possibly across the speaker. Hard to say. That sounds like the right value to go across the speaker to keep the tone low. Oh, we got one of those multiple pack hybrid packs. It's got capacitors and resistors inside. A simple one though, only 3 leads. There's not much going on here. 4 leads. The two wax papers, they are Sprague's. They look original. So I'm going to replace all 4 of those. The X-type right across the line here. X-type cap. This really can be anything between probably 0.02 and 0.1 microfarads. And these are usually rated for 275 volts. And here's the Y capacitor. This goes between the grounds. It goes between the artificial ground and chassis. And the Y capacitor is rated for protection and breakdown. This is a 0.027, something like that, 0.02. That could be a 0.02 to a 0.05. This is a 600 volt Mylar. And over here we have a 0.05 600 volt Mylar. So we've replaced the caps, the 2 electrolytics are in. Everything looks pretty good. Let's quickly check the resistors. See if we can get this in line where we can actually see something. Okay, what do we got over here? It looks like a 27K. It's up to 25K. Here's a 2.2 meg. It's up to 2.35 meg. I wouldn't change either one of those. Here's 150 ohms. Up to 175 ohms. Wouldn't change that one either. What do we got down here? 18 ohms maybe? Supposed to be 18. It's up to 20. I wouldn't change that one. And it looks like there's 1.5K hiding down there. Let's try to get to him. 1.559. I'm not going to change anything. You know, they've drifted high as they will, but nothing's taken damage to the point where the resistors are open or tripled in value. So do you remember why we wanted to add this 68 ohm resistor? As you can remember, we had the dial light that was a 2 watt unit or 1.5 watt unit, and we're replacing that with a type 47 bulb which only takes 150 milliamps at 6.3 volts. So we have to get rid of the rest of that through this resistor to simulate the other bulbs. We got to do, we have to put our shield can back on, make sure that's in there. One thing I liked about GE circuit is in the 50C5 output tube in the cathode they have a 150 ohm resistor, but it is not bypassed. A lot of times you'll see a bypass capacitor on that like this. By leaving that part off, not only is it nice because you have one less part to worry about that usually does go bad, but it provides negative feedback and improves the audio quality. So good job, GE. So you can see that there's probably 3 problems with this radio that would have prevented it from working, you know, just by plugging it in. 3 separate problems so far. First of all, you have the power supply electrolytics that were likely bad. You had that input line capacitor, the Black Beauty, which was probably bad. And perhaps any one of those other caps could have been bad. So, you know, you had a lot against you just turning it on, hoping it would work. And notice I didn't mention tubes, because it turns out that the tubes were all good in this radio, and wouldn't have helped if you swapped tubes, that's for sure. But now we have a safer situation. We can bring this thing up on a Variac with the tubes installed, and we can find out if there's anything actually electronic wrong with it. I mean, you still have the possibility that there's a bad coil or some other wiring thing we don't know about, but at least the radio is now ready to bring up electrically. Okay, here's the part you guys love, right? The smoke test. Out of my isolation transformer, I have my Variac. So the Variac is isolated, and that's going into the radio. And what we want to do is very slowly bring the Variac up, so that about the same time that the 35W4 and 50C5 light up, it starts to produce voltage, and it starts to produce voltage and starts to reform the capacitors. So let's start bringing this baby up. Make sure it's on. Let's go with that. Let's start bringing this up. Oh yes, I see some lighting. I see some lighting. I hear some hum. Okay, we're at 100%. Ooh, I'm getting a spot on the light. See that? Let's try tuning.
Like, why do I have to ask permission from every government agency across state lines or in my own state in order to exercise my right? That's
It's like, at least Gavin Newsom is a smooth wire. The bad dude overall, I think, in general. Oh, yeah, right?
So there's nothing that Madam Schiff, if you want somebody that you're going to hang out. They lost it for a second there on The View with E.T. versus Alien, like that comes out of the stomach and it's the...
So there's some hum, but I haven't got the chassis together yet. And of course, going through all this paraphernalia to get back to the AC line may be making a difference too. So I think I'm going to declare victory and put the chassis back together. Then we'll see if maybe the IF needs a little tune-up, but hey, never too early to declare victory. Okay, I just got it back in the chassis. Put the speaker in first. Looks pretty good. Yeah, it is what it is. Right on. Okay, so put the knobs back in. Gotta have some knobs. Okay, on, off, tuning. Okay, let's plug this thing in. On.
Is 15,000. Just randomly take your advice because you're an accountant. B, I want to know what other unintended consequences are. I never move forward blindly because the experts said.